Okay, fine. Chali, thank you. So we will continue here now. So the reaction is 83.55 kilonewton. ठीक है. This is 83.55. इतना आ रहा है क्या? Okay. So now we have got live load shear force as equal to 83.55 kilonewton. Okay. We have done with the analysis. Now we will do design. We have done with the analysis and now we will do design. अभी डिजाइन में क्या रहेगा? How to do design? Point of contract lecture. We are not interested in that point of contract lecture because already we have determined the maximum bending moment, that is 147.83. क्योंकि जब लोड सेंटर पर रहेगा that time it will produce the maximum bending moment, that is already determined. That is already determined. When the load will be at center, that will produce the maximum bending moment. Now in reference to design, please refer IRC 112. Please refer IRC 112. If you see different sections of this code, it is IRC 112 2011. Content, introduction, definition and notes, general, and it is section 5 that deals with the basis of design. It is on page number 18. So here we will discuss first the basis of design. It is on page number 18. It is section 5 of the code. The basis of design. Please refer that page number 18. Basis of design. The aim and design. It is clause 5.1. The aim of design. 5.1.1. The general performance requirement. The bridge as a complete structural system and it is a structural element should perform their function adequately and safely with appropriate degree of reliability during the design life and during construction. It must perform the function with appropriate degree of reliability for the entire life and during construction. It should withstand all actions. Actions are nothing but the loads consisting of applied and induced loads as well as environmental influences liable to occur, retaining its structural integrity and also withstand accidental loads. Example, barge impact, vehicular impact, etc. and earthquake load without causing damage which is disproportionate to the causative event. Adequacy of performance is defined in terms of serviceability, safety, durability and economy. There are four factors which are important. It must be serviceable, it must be safe. Serviceability, safety, durability means जितना भी उसका लाइफ टाइम है उसके लिए उसने सर्व करना चाहिए and economy. So these are the four factors on which the design must depend. Adequacy of the performance is defined in terms of serviceability, safety, durability and economy. It is next page, page number 19. It is clause 5.2. आपने ये सब पढ़ना चाहिए. Limit state philosophy design. The response of the structure when subjected to the different magnitude of loads lie in different states domains. Limit states are defined as the limit of domains beyond which the structure does not meet specified performance criteria. जैसे हमारा लिमिट स्टेट डिजाइन फिलॉसफी था, it is same thing. There is a limit to everything. Limit to deflection, there is limit to load, there is limit to shear, there is limit to bending moment. That is what the limit state is. वहां तक का उसने लेना चाहिए, उसके बियॉन्ड ले नहीं सकता है. स्ट्रक्चर मस्ट बी सर्विसेबल, इट मस्ट हैव सफिशिएंट स्ट्रेंथ. जैसे वहां पर दो टाइप के लिमिट स्टेट है, लिमिट स्टेट ऑफ स्ट्रेंथ एंड लिमिट स्टेट ऑफ सर्विसेबिलिटी. हियर आल्सो इट इज देयर. Two basic groups of the limit state are considered on page number 19. Please read this. It is on page number 19. What is that? Ultimate limit state, ULS. There are two type of limit states given here. One, it is clause 5.2. It is on page number 19. What is it? Number one, second part of that, the second point, part A of it, it is ultimate limit state. And it is abbreviated as ULS, ultimate limit state. Second, it is serviceability. Limit state. What is this serviceability limit state is? Abbreviated as SLS. See, as in case of limit state method, basically there are two type of limit states. So here also the two type of limit states are given. It is ultimate limit state, ULS, that is same as the limit state of strength. लिमिट स्टेट ऑफ स्ट्रेंथ में हम क्या कंसीडर करते हैं? फ्लेक्चर, शेयर, एक्सियल टेंशन, एक्सियल कॉम्प्रेशन, टॉर्शन. सो द सेम थिंग विल बी हियर. लिमिट स्टेट ऑफ सर्विसिबिलिटी में हम क्या कंसीडर करते हैं? डिफ्लेक्शन, ड्यूरेबिलिटी, fatigue, fire, cracking. So the same thing we have to consider here also. The structure must be safe in all. So there are two type of limit states which we have to consider here. The things are elaborately explained in clause 5.3 on page number 20. Limit states, ultimate limit states, limit state of strength. In limit state of serviceability, it is clause 5.3.1.2. It is on page number 20. This deals with the limit state of internal stresses. It comes under the serviceability limit state, SLS. The internal stresses developed in the material of the structural element shall not exceed the specified magnitude when subjected to the combination of serviceability design actions. The stresses are to be estimated using the resistance model to represent the behavior of the structure as stipulated in the code. 5.3.1.2 on page number 20. It deals with the limit state of internal stresses. अगर आपको याद रहेगा, हमने सेमेस्टर 7 में इन प्रीस्ट्रेस कंक्रीट, इफ यू विल रेफर IS 1343/2012, you will find guidelines for the limit state of serviceability, maximum compression and cracking. क्या था वो? क्या करते थे? The permissible values of stress in concrete at compression and transfer, the permissible values of stress in concrete in tension at transfer, the permissible values of stress in compression at working, the permissible values of stresses in tension at working. Whatever is the grade of concrete used, on the basis of that हमको permissible values of stresses मिलते थे और हम ये वेरीफाई करते थे the stresses must be within these limits. If the stresses acting are within these limits, it means that the element is safe in limit state of serviceability, maximum compression and cracking. हम ये कैसे इंश्योर करते थे? अगर आपको याद रहेगा, we ensure this by providing the minimum sectional modulus ZB must be greater than or equal to 1 minus eta ms plus mi divided by FBR. ZT must be greater than or equal to 1 minus eta ms plus mi divided by FTR. Is it right? अगर हमने सेक्शनल मॉड्यूलस ऐसे प्रोवाइड किया करस्पॉन्डिंग टू बॉटम फाइबर, अगर सेक्शनल मॉड्यूलस उतना प्रोवाइड किया करस्पॉन्डिंग टू द टॉप फाइबर, then it will be safe in the limited state of serviceability cracking. Similarly, here also we have to verify the element in the limited state of internal stresses. These are nothing but the internal stresses. Where do we use to get these internal stresses from? हमको ये इंटरनल स्ट्रेसेस कहां से मिलते थे? Where do we get the internal stresses from? अगर हम 1343 कोड देखेंगे, where do we get those values from? Permissible values of stresses in compression. अगर आपको याद रहेगा तो ऐसे कर्व्स अवेलेबल थे ट्रांसफर के लिए, सर्विस के लिए, प्री टेंशन के लिए, पोस्ट टेंशन के लिए, और वहां से हमको मिलते थे परमिसिबल वैल्यूज ऑफ स्ट्रेस इन कंप्रेशन एट ट्रांसफर, परमिसिबल वैल्यूज ऑफ स्ट्रेस इन कंप्रेशन एट वर्किंग ऑन द बेसिस ऑफ वेदर इट इज ए प्री टेंशन और पोस्ट टेंशन, राइट? वेदर इट इज सर्विस स्टेज और इट इज ट्रांसफर स्टेज. तो यहां से हमको ये वैल्यूज मिलते थे. और परमिसिबल वैल्यूज ऑफ इन कंक्रीट इन टेंशन एट ट्रांसफर, परमिसिबल वैल्यूज ऑफ स्ट्रेस इन टेंशन एट वर्किंग, ये कहां से मिलते थे? वेदर द एलिमेंट इज टाइप 1, वेदर द एलिमेंट इज टाइप 2, वेदर द एलिमेंट इज टाइप 3. ऑन द बेसिस ऑफ these permissible values of stresses we will have. अगर टाइप 1 एलिमेंट रहेगा तो क्या मतलब था? There is no tension permitted. There is no tension permitted at transfer as well as service stage. Type 2 में certain magnitude of tensile stresses are permitted such that the macro cracks will be there, not visible. Tensile stresses up to 3 Newton per mm square. और टाइप 3 में क्या था? The tensile stresses acting are hypothetical. सेक्शन क्रैक हो गया है, उसके आगे और टेंसाइल स्ट्रेसेस एक्ट हो रहे हैं, जबकि वैसे पॉसिबल नहीं है. Once the element is cracked, it will reduce the stresses. It will not be in a position to carry the further stresses. लेकिन हम अज्यूम करते थे और फर्दर हम स्ट्रेसेस उसमें और कितना एक्ट हो रहा है वो डिटरमाइन करते थे. बट दैट इज नॉट राइट. टाइप 3 एलिमेंट तक स्ट्रेसेस रीच ही नहीं होता है. उससे पहले क्रैक होने के बाद द स्ट्रेसेस विल गेट रिलीव्ड. तो टाइप 1, टाइप 2, टाइप 3 से हमको ये मिलता था. Permissible values of stresses in tension at transfer, in tension at working. यहां पर भी हमको ये सब वैल्यूज चाहिए. The condition is same, so as to verify. What is the condition? ZB must be greater than or equal to 1 minus eta ms plus mi divided by FBR. ZT must be greater than or equal to 1 minus eta ms plus mi divided by FTR. ये इक्वेशन हमारे लिए कुछ नए नहीं है. If I want the element to be safe in the limited state of serviceability internal stresses with reference to that clause 5.3, if I want the element to be safe, then these conditions are to be satisfied. What is MS? Moment because of dead load. What is MI? The moment because of imposed load. The bending moment because of imposed load is available. This is nothing but MI. What about the bending moment because of dead load? अभी मुझे वो सब आंसर चाहिए आपके पास से. Bending, dead load, bending moment. When 1 meter strip, when strip is considered in deck slab, dead load bending moment due to the deck slab, dead load bending moment due to wearing coat, when strip is considered from footpath, then what is the dead load bending moment? ये क्या था? बिकॉज ऑफ डेक स्लैब प्लस बिकॉज ऑफ फुटपाथ plus because of the railing, the total bending moment was there. So please give me these answers. Dead load bending moment. Whatever these moments are, this is the bending moment per meter width. क्योंकि हमने जो भी सॉल्व किया है, हमने यहाँ पर फॉर 1 मीटर वाइड स्लैब वी हैव सॉल्व फॉर 1 मीटर. ये हमने यहाँ से लिया तो फॉर 1 मीटर वाइड स्लैब. It means that whatever this bending moment or shear force, whatever the bending moments here, all these are per meter width of deck slab. हमने deck slab का 1 मीटर width लिया है, ये per meter width of slab. For 1 मीटर width के लिए इतना bending moment act होने वाला है. That is what we have calculated. When the strip is considered in the deck slab, please give me these answers. अभी मुझे ये आंसर चाहिए सब जो हमने एकदम पहला लेक्चर या दूसरा लेक्चर में किया था रहेगा. डेड लोड बेंडिंग मोमेंट ड्यू टू द डेक स्लैब, हाउ मच डेट इज. चलिए मुझे आंसर दीजिए सब. ये was it 113.91? Was it 26.33 kilonewton meter for 1 meter wide slab? Is it right? How much it was because of footpath, deck slab and railing together? 225.28 kilonewton meter. Do we have these answers available? मुझे ये आंसर पहले हमने कैलकुलेट करके रखे थे. When the strip is considered in deck slab, right? When the strip is considered in the footpath, these were the bending moments. Now how much is the dead load bending moment? Dead load bending moment मैंने कितना लेना चाहिए? So as to consider the bending moment because of dead load, please consider IRC 6. Please consider IRC 6. And on this IRC 6, please refer this page number 95. It is table B3 on page number 95 of IRC 6. क्या लिखा है इस टेबल में? Partial safety factor for verification of serviceability limit state. So what we are talking here is about the limit state of serviceability. तो partial safety factor for load हमने कितना लेना चाहिए? What must be the partial safety factor for load? इसमें अगर हम ये very first देखते हैं, it is permanent load. So in that case we have to consider as 1. It is 2 is for the surfacing. For surfacing we have to consider 1.2. Variable loads, that is for the live load, it is to be considered as 1. It means that the value of gamma f here is 1. The value of gamma f here is 1.2 because this is the varying code. क्योंकि ये पॉसिबल है, लोड कम ज्यादा हो सकता है, चेंज हो सकता है. एंड ये भी तो डेड लोड ही है, डेड लोड, राइट. इसके लिए भी हमको कंसीडर करना है gamma f is equal to 1 only. और लाइव लोड के लिए भी we have to consider the value of gamma f is equal to 1. It is given here in table 3 B3 page number 95. Is it okay? Please refer page number 95 table B3. You will get partial safety factor for different nature of loads. For dead load, because of deck slab, it is 1. For wearing code for surfacing, it is 1.2. यहाँ पर डेक स्लैब, फुटपाथ, रेलिंग ये सब कांस्टेंट रहेगा, सो दैट इज 1. वहां पर लाइव लोड है फॉर रोलिंग लोड्स अगेन, और फॉर द लाइव लोड्स और द वेरिएबल लोड्स दैट इज टू बी कंसीडर्ड एज 1. कैरेज वे लोड एंड एसोसिएटेड लोड्स दैट इज टू बी कंसीडर्ड एज 1. ओके, सो व्हाट इज द मोमेंट mi? The partial safety factor is to be considered as 1. So it will be 147.83 kilonewton meter. It is this. What about value of ms? अब मुझे ms देखना पड़ेगा ये कॉम्बिनेशन से. It is 113.91 plus 1.2 multiplied by 26.33. और यहाँ पर तो 1 ही है. So it is 1 multiplied by 225.28. So this is going to be 225.28. और यहाँ का जो भी आंसर आएगा it is 26 into 1.2, थोड़ा सा ज्यादा हो जाएगा 26 से 113. और उसमें अगर ये 20-30 भी ऐड करते तो 150, और ये तो 225 है. So this is going to be more only. So I will consider the bending moment because of the dead load as equal to 225.28, because this is going to be less than 225.28 kilonewton meter. So the greater of the two I will consider as the bending moment because of dead load. So these are the values of mi and ms. The partial safety factor for loads are given. Now the partial safety factors are available. The moments are available because of the dead load and imposed load. Next, we have to get the values of ZB, ZT, MS, MI, ये सब अवेलेबल है. What is next required is eta. What is eta? Loss factor हमको पता है. Whatever the pressurizing force applied in the beginning, that will not remain constant with the time, but that will keep on changing and it will reduce with the time. तो टाइम के बाद ये वैल्यू कम हो जाएगा. So that should be given in the question. अगर नहीं दिया जाएगा, then we have to assume some value. कितना assume करेंगे, because it is not given in the question. How much you want to assume the value of eta? What is the value of eta you want to assume? कितना कंसीडर करेंगे eta? कितना कंसीडर करेंगे वैल्यू ऑफ बीटा? नहीं दिया है क्वेश्चन में. कितना अज्यूम करना चाहिए? सुफियान, अच्छा सुफियान भी है या सुफियान भी भाग गया अभी? हाउ मच यू वांट टू अज्यूम द वैल्यू ऑफ बीटा? नहीं दिया है क्वेश्चन में. Say I assume eta is equal to 0.8, means I have considered that say there is 20% loss. So now eta is available, ms is available, mi is available. What you require is next value of FBR. What is equation for FBR? ये सब आपके पास अवेलेबल रहेंगे. Okay, thank you Sufyan. What is the equation for FBR? The equation for FBR is eta FCT minus FTW. And what is FTR? That will be equal to FCW minus eta FTT. Okay, fine. अब हमको ये सब वैल्यूज चाहिए. Where we can get all these values from? We can get all these values from IRC 112. Please refer IRC 112. It is, these values are available in IRC 112. मुझे जरा ढूंढने दो कहां पर रहेगा, where these values will be. These values will be available IRC 112. कहाँ रहेगा 112 में? परमिसिबल स्ट्रेसेस कहाँ मिलेंगे? Where will I get the permissible stresses? Material quality, workmanship. हाँ, please refer Annexure 4. Annexure 4. It is clause 4.8. A 4.8 on page number 265. What this clause says? Please refer page number 265. Clause A 4.8. It is Annexure 4. What is that? Requirement of pre-stress concrete members. This covers pre-stress concrete members, post-tension determinate structures, wherein adequate magnitude of the pre-stressing force is applied to the member in order to improve the effective resistance of concrete to tensile forces arising from the loading effect at working load levels. The working load shall be as per IRC 6 table 1. तो वो हमने लोड ऑलरेडी कंसीडर कर लिया है. प्लीज कंसीडर पेज नंबर 266 A 4.8.3. It is page number 266. Permissible stresses in concrete. I will read here permissible temporary stresses in concrete. So part C of that. At full transfer, that is at the transfer stage. At full transfer, the cube strength of concrete shall not be less than 0.8 FCK. What is given here? The initial stress in concrete must be equal to 0.8 times of FCK. Temporary compressive stresses in extreme fiber in concrete, including stage pre-stressing, shall not exceed 0.5 times of Fg. So it is the stress in concrete at transfer is equal to 0.5 times of FCI or equal to 30 MPa, whichever is minimum. Whichever is minimum. These are the permissible values. It is part C on page number 266. At full transfer, the cube strength of concrete shall not be less than C. What it means? अगर आपको याद रहेगा, in IS 1343 2012 हमने क्या किया था? At what strength the stresses can be transferred from steel to concrete? At transfer stage, the concrete must have minimum 50% of its characteristic strength. वहां पर ये क्लॉज था. FCI must be equal to 0.5 times of FCK. This was the clause. What is that? At transfer, FCI is nothing but the initial strength of concrete. That is at the stage of transfer. When the stresses are getting transferred from steel to concrete, what must be the minimum strength of concrete? 0.5 times of FCK. That is the 50% of the characteristic compressive strength of concrete. That was for general pre-stress concrete structures or components. That was for general pre-stress concrete structures and components. But bridge is a structure of major importance. तो यहां पर क्या दिया है? At the time of transfer, FCI, what must be the strength of concrete at the stage of transfer? Minimum 80% of FCK. Right? The concrete must have achieved 80% of the compressive strength of concrete, then only the stresses can be transferred. Whereas अगर आपको याद रहेगा IS 1343 में how much it was? 0.5 times of FCK. That is one change. और परमिसिबल वैल्यूज ऑफ स्ट्रेसेस जैसे मैंने आपको बताया था वहां पर इस तरह के कर्व थे और वो हम कर्व से कैलकुलेट करते थे. प्री टेंशन है या पोस्ट टेंशन है, ट्रांसफर स्टेज है या सर्विस स्टेज है, एंड वी यूज्ड टू गेट द वैल्यूज फ्रॉम देयर, द परमिसिबल वैल्यूज ऑफ कॉम्प्रेसिव स्ट्रेसेस. लेकिन यहां पर वी आर हैविंग सम डिफरेंट गाइडलाइंस as per this clause A 4.8.3 page 266 of IRC 2112 with reference to this code 2011. The permissible values of stress in compression and transfer must be 0.5 times of FCK or 30 MPa, whichever is minimum. Permissible values of stress in tension and transfer in concrete. What is it? The temporary tensile stresses. Temporary means transfer stage के ऊपर, because those are not permanent. Temporary tensile stresses in the extreme fiber of concrete shall not exceed 1/10 of the permissible temporary compressive stresses in concrete. So it is 1/10 of FCT. Permissible values of tensile stresses. This is part D. Next is part E of the code. It is 1 का CD. Period 2 का A. The compressive stress in concrete under service shall not exceed 0.33 times of FCK. The permissible values of stresses in compression at working is equal to 0.33 times of FCK, not more than this. No tensile stresses shall be permitted in the concrete during the service. B. The permissible values of stresses in concrete in tension at working are equal to 0. All these guidelines are available on page 266. This is this. Permissible stresses in concrete. So these are the permissible values of stresses. अभी क्वेश्चन में देना चाहिए ग्रेड ऑफ कंक्रीट, एफसीके देना चाहिए, एफसीआई भी देना चाहिए. मैंने पहले बोला था कि जब व्हेन आई वाज गिविंग यू द क्वेश्चन उसी वक्त मैंने बोला था कि हम क्या करेंगे, बहुत सारा हमने एक स्पेस छोड़ दिया था क्वेश्चन लिखकर, व्हाट एवर डेटा रिक्वायर्ड बाय दैट वी विल कीप ऑन आईडी. तो वहां पर ऐड कीजिए FCK suppose 60 MPa है and suppose FCI is equal to 50 MPa. देखिए ये पॉसिबल होता है क्या? FCI 50 MPa चलेगा क्या? 0.8 टाइम्स ऑफ FCK रहना चाहिए, 0.8 टाइम्स ऑफ 60, so that is 48 MPa. इसका मतलब at the time of transfer the minimum strength of concrete must be 48 and how much is the strength we have considered here? 50. So it is all right. ये हमने डेटा add in the question. This data we will add in the question. Okay. So FCK is 60 MPa, say FCI is equal to 50 MPa. Initial strength of concrete must be minimum 80% of the characteristic compressive strength. Fine. चलिए. Now determine this FCT. 0.5 times of FCK, FCI. 0.5 multiplied by 50, that will be equal to 25, or this is 30. The lesser of the two we have to consider, so that is 25 MPa. So we have got the value of FCT is equal to 25 MPa. Now FTT, the permissible tensile stresses इतना है, लेकिन as we know that bridge is a structure of major importance, यहाँ पर we will add in the question, consider type 1 element. What do you mean by type 1 element? If it is a type 1 element, the permissible values of stresses in concrete in tension at transfer is 0. The permissible values of stresses in concrete in tension at working will be equal to 0. No tensile stress are permitted. ये तो वैसे भी 0 ही था, लेकिन इसको भी हमने 0 कर दिया क्योंकि we have assumed it as the type 1 element. अगर ये type 1 element नहीं दिया रहेगा, so it will be 1/10 of this. So that will be 1/10 of 25. So it means that this must be equal to minus 2.5. Minus that indicates tension. तो यहाँ पर फिर ये minus 2.5 हो जाता था. Permissible values of stresses in concrete in tension and transfer. लेकिन हमने यहाँ पर type 1 element consider कर लिया है, so this whole will become 0. Now what is FCW? The permissible values of stress in concrete at working 0.33 times of FCK. So that will be 0.33 multiplied by 60. So that will be equal to 19.8 MPa. Now all the required things are available. Get the value of FBR and tell me the value of FTR. It will be 0.8. Permissible values of stress in concrete in compression and transfer is 25 minus 0. So it will be equal to 20 MPa. It is 19.8 minus 0.8 into 0. So that will be equal to 19.8 MPa. Okay, fine. So we have got all the required answers. So you tell me now, as it is a rectangular section, what is the value of ZB is equal to ZT is equal to Z, which is provided. हमने कितना प्रोवाइड किया है? Width is considered as 1 meter, depth is 450 meter, so it is BD square by 6. How much it will be if it is BD square by 6? What is the value of Z provided? Please give me the answer. The value of sectional modulus provided. और ये दोनों में से कौन क्रिटिकल रहेगा? The numerator is same 1 minus eta ms, 1 minus eta ms plus mi plus mi. So the numerator is same. यहाँ पर FBR का वैल्यू है 20. Numerator is same. FTR का वैल्यू है 19.8. What do you think, in which of the case the sectional modulus required will be more? As it is rectangular, so one which is greater we will solve corresponding to that because that will be critical. तो यहाँ पर 20 से डिवाइड कर रहे हैं, यहाँ 19.8 से. The numerator is same. As it is a rectangular section, so the ZB and ZT must be same. So I will say that the top fiber is critical. So get the value of ZT required. That is nothing but the Z required. From here, 1 minus eta is 0.8. The moment because of self weight is 225.28 plus moment because of imposed load is 147.83. Whole will get multiplied by 10 raised to power 6 divided by 19.8, and we will get here the value of Z required. This is the value of Z provided. चलिए मुझे दीजिए दो आंसर, Z provided and Z required, and comparing the two I will comment here whether it is safe or unsafe. What is the value of Z required? How much is the value of Z provided? Hmm. 33.75. It is 33.75 into 10 raised to power 6 mm cube. This is provided. and what is required? मुझे लगता है दूसरे लोग इंटरेस्ट ले रहे हैं या नहीं ले रहे हैं, अटेंड कर रहे हैं या नहीं कर रहे हैं, बट इट इज टोटली अनफेयर। यार नुकसान तुम्हारा होगा बच्चों अगर तुम अटेंड नहीं करोगे। अगर सिंसियरली जो लोग रेगुलर अटेंड करेंगे, सिंसियरली अटेंड करेंगे, मेरे साथ अटैच रहेंगे, उनको सब समझ में आएगा कि ये क्या चल रहा है। जो लोग अटेंड नहीं करेंगे शायद दे में फेस डिफिकल्टीज। इट इज 9.7। ओके 9.7। आई डोंट नो, ये आप जो भी आंसर दे रहे हो मैं उसको यहाँ कर रहा हूँ। दिस इज रिक्वायर्ड प्रोवाइडेड इज मोर, सो इट इज लेस देन 33.75 into 10 raised to power 6 mm³, so it is safe. The structure is safe in limit state of serviceability, SLS, सर्विसिबिलिटी लिमिट स्टेट, इंटरनल स्ट्रेसेस मैंने आपको बताया है, वो क्लॉज 5.3 वगैरह जो था, इंटरनल स्ट्रेसेस, एंड इट इज सेफ इन दैट। अब इसके बाद हम क्या करते हैं? वी डिटरमाइन द वैल्यू ऑफ पी, वी डिटरमाइन द वैल्यू ऑफ एक्सेंट्रिसिटी। फिर हम देखते हैं कि इतना हम एक्सेंट्रिसिटी प्रोवाइड कर सकते हैं क्या। अगर नहीं है देन वी नीड टू रिस्ट्रिक्ट द एक्सेंट्रिसिटी, रिवाइज द मैग्नीट्यूड ऑफ प्रीस्ट्रेसिंग फोर्स। फिर हमको एरिया ऑफ स्टील डिटरमाइन करना पड़ेगा। Then we have to check it for flexure and we have to check it for shear, and here the solution ends. अभी बहुत एक बार एनालिसिस हो गया तो डिजाइन पार्ट इज वेरी रूटीन। सबसे ज्यादा इंपॉर्टेंट है एनालिसिस। अगर एक बार एनालिसिस पार्ट कंप्लीट हो जाता है then the design part is very routine. It is all same as we had done in semester 7 in pre-stress concrete elective. थोड़े थोड़े गाइडलाइन चेंज होंगे। प्रीस्ट्रेसिंग फोर्स, एक्सेंट्रिसिटी, प्रीस्ट्रेसिंग फोर्स अगर एक्सेंट्रिसिटी लिमिट करना है देन रिवाइज प्रीस्ट्रेसिंग फोर्स, एरिया ऑफ स्टील, चेक फॉर फ्लेक्चर, चेक फॉर शियर, ये सब हमने ऑलरेडी पहले किया है, द सेम इक्वेशंस। परमिसिबल लिमिट थोड़े चेंज होते रहेंगे एंड वी नीड टू रेफर दिस। एनालिसिस चेंज रहेगा, लोड कहां एक्ट हो रहा है, कितना लोड एक्ट हो रहा है, कैसे लोड एक्ट हो रहा है, उसका क्या बिहेवियर आएगा, कहां पर उसका इफेक्ट आएगा, दैट इज इंपॉर्टेंट। वंस यू अंडरस्टूड दैट, डिजाइन इज वेरी रूटीन प्रोसीजर। ठीक है, सो हाउ डू वी गेट द मैग्नीट्यूड ऑफ प्रीस्ट्रेसिंग फोर्स? हाउ डू वी गेट द मैग्नीट्यूड ऑफ प्रीस्ट्रेसिंग फोर्स? प्रीस्ट्रेसिंग फोर्स का मैग्नीट्यूड कैसे मिलेगा? आपको ये सब इक्वेशन याद है? ए इन ब्रैकेट जेड बी एफ इंफीरियर प्लस जेड टी F superior divided by ZB plus ZT. As it is a rectangular section, ZB is equal to ZT is equal to Z. That can be taken common and cancel. So it will be A by 2 F inferior plus F superior. How we can have the value of F inferior? ये सब equations आपको याद है पहले से ही। What is the equation of F inferior? 1 upon eta in bracket FTW plus MS upon ZB plus MI upon ZB. And what is F superior? That will be equal to FTT minus MS upon ZT. Moment because of self weight, the section modulus provided. यहां पर हम जो भी यूज करते हैं that is nothing but the Z provided we use, जितना हमने प्रोवाइड किया है। FTT, FTW, permissible values of stress in tension at transfer and tension at working are 0 because we have assumed these as the type 1 element. Eta, MS, MB, ZB, ZT, all these values are available. Substitute here, get F inferior, F superior. Put here, the area is also available, get the प्रीस्ट्रेसिंग फोर्स। तो अभी मुझे ये F inferior, F superior का वैल्यू कैलकुलेट करके रखिए, यहाँ सब्स्टिट्यूट कीजिए, प्रीस्ट्रेसिंग फोर्स लीजिए, एक्सेंट्रिसिटी लीजिए, द रिमेनिंग पार्ट यू कैन डू। मुझे एक्सप्लेन करके बताइए पीई वगैरह कहां तक आता है। So please give me the answer for the magnitude of pressurizing force and corresponding eccentricity. I am concluding lecture here. Okay. लेक्चर सिंसियरली अटेंड करो यार, कैसे मजबूर कर सकते हैं तुमको? तुम्हारी जिम्मेदारी है बच्चों सीखने के लिए, है ना? इट इज यू टू लर्न. चलिए ठीक है, थैंक यू.